Hey everybody, today we'll do another video, and today we will do a request. Somebody requested me, not on the channel but on in the kind of personal. He requested that he wanted to learn more about transformers. So he wanted to learn more about transformers. So we want to do a video so we can learn more, a little more about transformers, right? So, and this marker is not good. Let me see if I can use this again. It's a very wide marker, so I need a little pointy one. This is not working. So right, so we have alright, so we just doing a demonstration right here. So that's how a transformer look like it. So when you see a line like this, it's a symbol for the transformer, right? So this is the iron core. This right here representing this, right? So transformers are very interesting because what they do is this coils right here, the turns, it's called turns, N, right? So N is equal to, a small n is equal to N1 over N2. Okay, so N1 is this one, right? It's the primary, and the N2 is this one, right? So now you can see that this transformer, I got it 1, 2, 3, 4, 1, 2, 3, right? So I have ratio, I got more turns over here than over here. So in this case, that's how you have a transformer, right? But if you have it at N1 equal N2, then you're not gonna have a transformer because you're not changing anything, right? In a transformer, right? So in order to have a transformer, you get it. You only have a two type, which is a step-up transformer or a step-down transformer, right? Of course, when I say type, I mean function-wise, right? Functionality-wise. But you have a delta and also you have a Y-type transformer. So that's, when I say, two type of transformer, two type of function of the transformer, you have a step-up transformer and a step-down transformer, right? In this case, we have more turns over here, and we have less turns over here. So therefore, we have, in this case, right, called a primary, right, and this called secondary, right? So I get more turns over here, I got less turns over here, so therefore it's a step down transformer, right? Same thing over here, right? Well, this is basically this is how you do it in the drawing, this is how you see it in the test books. Okay, so N1 is, okay, so if this marker's not really cooperating with me, but so if N1 is greater than N2, then you have a step down transformer. Right? If N1 is less than N2, you have a step up transformer. Right? This step up transformer. Right? So now think about it. So this is what make the transformer, right? It's just coil. It's just a bunch of copper wire wrap around this iron core. This right here is called, normally is called the iron core. So basically it generates a magnetic field right around this, and then it generates what's called a flux, right? So the flux is generated by these two things, right? Because you induce a current in both sides of this, and you induce a current over here, and depending on what the current is being induced over here, it will create a magnetic flux. And that change in magnetic flux, it will create another current in the secondary, and this also will create another magnetic flux, and it will going like this, back and forth like that. So it will create this magnetic flux going around. So now, so what is the magnetic flux, right? So, it is a rate to change in the magnetic flux, which is basically, so technically what it does is to change the voltage. Okay, so the V, so V, this is, so V, right? V is equal to the change, in flux, right? Multiplied by one of this guy, so N1, so N1, right? V1 is equal to N1 dV dt, right? So this is the change in flux. Now, so that's how transformers work, actually. I mean, I'm not gonna do all this bunch of math right now, all this, but in simplicity, what basically V2 is equal to N2 dV over dt, right? So now that is what is being changed according to the rotations, right? According to the rotation, you generate a change in flux, right? That's what this derivative means. So, so interestingly enough, that when you have a transformer that is actually, it's very interesting, because you have like N1, right? over N2 is equal to B1 over B2, right? But then this is equal to something else, which is the current. But when you do the current, you do the opposite, right? So you do basically the opposite, was going to be I2 over I1. And the reason for that is because you need to, you need to make sense out of it. So so remember that the current of this, right? So the higher the voltage, the less is the current, right? So in this case, the secondary go with this, and the primary go with this, right? The primary and the current goes to B1, B primary, and the secondary of the I2 and the secondary go with the voltage in the secondary, right? So that's how basically transformers work. It's pretty neat, actually. What we can do is, create an example and see if this makes sense, right? Because technically, at the end of the day, that's why we need to learn. We need to learn real applications. We don't, that's basically, because if you start looking for like information online right now, there's a bunch of guys online saying that this guy right here is a transformer. This is not a transformer. This is a power supply, right? This take AC voltage and convert it to DC voltage. That's what I have right here, the DC voltage coming out. That's why you want to learn electricity, please, and I say this, please, don't learn from a physicist. Learn from either an electrician that know what he's doing in the field, or learn from somebody who's an engineer. There's a bunch of guys over here that's online that's saying that this is a transformer. This is not a transformer. This is a power supply. Some guys said, oh well, got an AC coming in and they got a voltage coming out for my small device. Yeah, but this is a power supply. This is just basically take AC and turn it into DC power. So DC current, AC alternating current, and you got a DC current on the other side. So similar concept, but not the same. So that this is a power supply that the both of those that I showed you, there are a power supply, right? And by saying this, I am not saying that the physicists are not really smart. They are smart people. Smart. But they don't know how to explain electricity or components, what they do. But if you want to learn the theory, then might as well watch somebody who is a physicist, because they might be better on explaining the theory of electricity, right? All the protons, all the neutrons, all this stuff, the electrons. They might have a better, explanation for that stuff, right? Positive and negative and all that stuff, and mathematically they can make sense. But when coming to this is not a transformer. Please, this is not a transformer. Transformer is huge. Those things that you see in the poles outside, those are transformers. Okay, so this little thing like this, or maybe the one that I showed you, those are a power supply. Power supply. Power supply. It's totally different. Totally different. Power supply is totally different, right? So I just want to make sure that in this, Again, it's same concept, but not, it's different function. It's a different function. So if you want to learn real applications for, electricity, again, try to learn from somebody who, if you want to learn from a physicist, but try to find somebody who is understand electrical components applications, right? Because technically a transformer, so you take the primary is coming in, the secondary is coming out, right? Now the question is, right now, what do I have? I have, let's say for example, I have this, right? This is coming in, I have it like from the pole, I got power to this, going to a transformer, but over here, in the secondary, I don't have anything, right? Just have it open. Secondary, I don't have anything, right? Do I have anything? Well, it's the same thing. See this? When I plug in these two things in there, if I don't plug in a phone to this, or I don't plug in any type of device, I have an open circuit. I don't have no load. This is not a load. A load will be consuming power, taking electricity, taking this power coming from this, so it making charging a phone, right? Then it turns into a load. Right now I don't have nothing, right? It's an open secondary. Now, once I add a load right here, so now I have something like this. I got something like this, right? A load. Now I have something. See, now I have something connected to it. Now I have this. It's going to induce a magnetic flux going this way and then going that way, right? And I'm not gonna go through the right hand rule and stuff like that. How this turns in, and in the direction where the thumb is sticking up is the direction of the current. I'm not gonna do that right now, right? So I just want to teach you the basic concept of the transformer. But that's what it does, right? So now the primary right here, primary coming in, right? And remember what we say that we say that N1 equal N1 over N2 is equal to B1 over B2, which is equal to I2 over I1. Now, let's do this. Let's say, for example, that you have some type of you have a panel, right? Electrical panel. And you want to feed, and you have a bunch of AC power, AC unit, and then you have a bunch of mechanical unit that take 480 volt, 480, right? Take 480 volts, right? Now, but you need, for the receptacles like this, or for the little things like this, you're not gonna plug in this guy in a 480, you will blow it up. You don't want to do that, right? It will destroy it. So you need a less power, right? For this you need 120 volts, right? So how you make a 120 volt if you have a 480 coming in? To have 480 coming in, you need right here 120 coming out. Okay, so you have a three-phase system coming in, 480, and then you need out in this side right here, you need 120. How you do that? Well, you need to get on a step-down transformer, which already have it right here, and then you need to make the secondary to be 208 volt, 208 volt, three phase, right? 208 volt, three phase, right? Three with a little thing like that, right? Three phase. Now this is when, okay, so now you have a secondary, you got a primary voltage, you got a secondary voltage, right? Because out of this you can get 120 with the neutral, right? And then you can plug in your phone safely. Okay? Now, this is the thing. Now, let's say for example you do your math and you did all the receptacles in the building, and you know that in this guy right here you need around 225 volts. In this 225 amps, right? 225 amps. The question is, what will be the current in the primary if you know that in this side right here you need, because you do the mathematics, you add all the devices and then you take all the you know, and then you find out that you need 225 secondary is equal to secondary current, or you can say, you know, you'll just do I2 equal to 225 amps, right? Okay, so the question is, what do you need in the primary? Well, let's use the formula, right? So we know that we have a B1, we have a B2, we have an I2, we don't have an I1. See? So now, V2 is 208 volt, V1 is 480 volt. So what do I do? So what I do is the following. So 480, right, over 208 is equal to what? Equal to I, right, I2, which I already have it. I already have I2, right? I already have I2, 225 amps, right? And I have on the bottom over here, I got a what? I got I1, I need to find that. I need to find I1. So what do I do? Okay, so let's do that, right? So, okay, another thing I want to explain right here, real quick. So another thing that is true about this transformer, because again, given the physicists credit, right? Just please don't focus in too much as a physicist to learn applications on electricity, but the theory, right? Conservation of energy has to hold true. Conservation of energy. What is conservation of energy, right? The power that is coming in over here is the same that power coming out over here. Again, power coming in is equal to power coming out. Okay, so P in equal P out. And that has to be true. They gotta be true, right? So what do I do? Now let's do this, and then we prove it with this, right? So let's do this. Okay, so we solve for, so cross multiply these guys, right? So you got 208 times 225 is equal to 46800. So 46800 is equal to 480. Oops. 480 I2, right? I1, I'm sorry. I1, that's I1. Now, divide that, right? So now we divide by 480. Divided by 480. And you get that 480, right? So now divide that guy by 480, and you get, I got it, 97.5, right? 97.5 amps. I could round this to 100 amps because you don't get panels that are in this. If you wanted, again, doing the real life situation, you don't get panels that are 97.5. But I live this like this just to prove that this is true, right? Okay, so what is power, right? So power is equal to what? Is equal to V, right? Times the square root of three-phase system times I, right? Times the current, right? So in this case, if you want to calculate the power coming in over here, coming out over here, what are you going to do, right? This is I1, right? So you know what is I1. So power is equal to what? Is equal to 208 times 208 times 1.732, the square root of 3, right? Just an approximation. 1.732 times 225 amps, right? So when you do that, you get that the power is equal to, so power is going to be equal to what? It's going to be equal to, and this is power of the secondary, okay? So you can put power secondary, right there, power secondary, just to prove that it's true. So 208 times 1.732 times 225 is equal to, so power right here is equal to PS, right? PS is equal to 81,057.6, right? And this is, so, and this is VA, right? Now, let's find the power of the primary. We want to claim that this is true, right? Now we want to find the power coming in. Do the same thing, right? So P primary, right, is equal to what? Is equal to 480 coming in times 1.732 times 97.5. Because if I use 100, not gonna be the same, right? Now you understand that, why I use 97.5. So now we do that, right? So now we do 480 times 1.732 times 1.732 times 97.5. Okay, so and power of the primary, right, is equal to what? Is equal to 81,057.5. See, the power is the same. Power of the primary has to be equal the power of the secondary. That is the truth, right? Now, okay, so now you know that you need a transformer that is 100 amps, and you can round this up to 100 amps and buy a transformer that has a primary of 480 and a primary current of of primary current of 100 amps, right? And that will be enough, right? And now you can feed your receptacles, right, in your design. Now, I mean, this is for real life application, right? For the test. Your teacher might want to trick you. He might want to give you this, right? And he might give you this. He might give you power in the secondary, and then we'll say find the power of the primary. Well, you know already that the power of the secondary has to be equal to the power of the primary. You know, that would be one answer. And then to find the current, then you do the opposite, right? So let's say that he give you the current of the secondary and the power of the secondary, and you need to find the voltage, you know, right here, right? You can find it, and also you can find because you know the power coming in is going to be equal power coming out. Now, if you have the voltage, you can find the current on your primary, right? So, you know, this transformers are, you know, very good, very good concept to learn. So, but again, that's how they work. They generate a magnetic field inside, all right, and they induce the magnetic field inside. And then they change the flux, increases and decreases the EMF, right? The electromagnetic force inside this. When you change the electromagnetic force is when you know, make all these changes. Either it has to be affecting each other. Whatever this does will affect this, and whatever this does, it will affect this. So, but you need to balance that out inside. So that's how transformers work. So I hope this video helped, and I will see you in the next video. Thank you for watching.